Mr. Hansen. We're kind of picking up with factoring here. We left off by factoring some trinomials and with a coefficient of 1 in front. We're going to do one without a coefficient of 1 in front this time, something like this here. But first, look at this. This is a polynomial. It has 4 terms here. And we're gonna try a new strategy here that'll help us with the 3-term polynomials in just a minute. So look at these 4 terms. There's a possibility that you could kind of group them. This is called factoring by grouping. Notice there's some common factors in the first 2 terms, and there's also a common factor in the last 2 terms. So let's just factor out something out of those first 2 terms. I'm seeing a 2x, and that leaves us with 4x plus 3. If we were to distribute that out, we'd see 8x squared plus 6x. And then over here we've got, I think we can take a 3 out of the 12 and a 3 out of the 9. So 3 there, that leaves us with 4x plus 3 also. And this is kind of handy because we're multiplying 2x by this quantity here, and we're multiplying 3 by that same quantity. So we're going to use the distributive property since we're multiplying 2x by something and then 3 by that same thing. It's like this. It's like 2x plus 3 times that thing. And that thing happens to be 4x plus 3. And so there you have it. We've just taken a polynomial expression with 4 terms. We've grouped 2 of them together, and using the distributive property, we're able to break it down into 2 factors, which would eventually lead us to solving a problem if this was a quadratic equation. So let's talk about how that might help us with a trinomial. Over here on the right side, we've got 6x squared plus x minus 15. And I want you to think a little bit for a minute. We're going to come up with the number 6 times negative 15, and that's going to be negative 90. And if you're thinking about FOIL for just a minute, let's just think about this A and B and C and D. When we're FOILing, we multiply the outer by the A and D together and the B and C together. And so what that gets us is an outer term and an inner term, and then we add up those 2 terms to get the middle term. So that's why we're multiplying 6 and negative 15 together to get negative 90. Let's take a look at the factors of negative 90 that we have to work with. We could work with 45 and negative 2. We could work with negative 45 and 2. We could work with 30 and negative 3. We could work with negative 30 and 3. We could work with 15 and 6. We could work with a negative 6 or negative 15 and 6. We could work with, what else is there, 10 and negative 9 and negative 9 and 10. And I may have missed one, but I think this is enough for our purposes here. So we would want to use 2 numbers that add up to my middle term here. And so it looks like we're going to have to go with 10 and negative 9. So from this point, we've got 6x squared plus 10x minus 9x minus 15. Do you see how 1x is the same thing as 10x minus 9x? So we've kind of expanded it to this idea of a polynomial expression with 4 terms, and now we're going to use the grouping idea. And for any trinomial that's factorable, this method always works. Not that all trinomials are factorable, but for anyone that is, this method would work. So let's go ahead and group this together kind of like that. I see a common factor in the first group, and it looks like it's going to be 2x, and we have 3x plus 5 left. And in the second group, my common factor is maybe negative 3, and we have 3x plus 5 left there. Now, using that old distributive property trick again, we're saying 2x times something minus 3 times something equals 2x minus 3 times something. And that something is going to be 3x plus 5 right there. Okay, it's good to just kind of double check your work and see if we multiplied that back out, if we get something like this. So first term, 2x times 3x, 6x squared. Outer term, 2x times 5, 10x, which is kind of what we wanted. Inner term, 3x times negative 3x, negative 9x, which is what we kind of wanted. And last term, negative 3 times 5 is negative 15. And there we have it. If we combine those two terms, we'll have what we started with originally right up here. So this method works all the time. Other people sometimes would do something like this, and this isn't a bad thing to do. It just takes more time sometimes. They do a guess and check method. They think of all the factors of 6, and maybe they start with 3 and 2, and then they think of the factors of 5, and negative 1, and then they'd kind of guess and check, well, that adds up to 15, that adds up to negative 2, that's 13. That's not what we want. So then maybe they'd change this out a little bit to, maybe they would go, oh, that's negative 15, sorry. Anyway, there's a guess and check approach to this. I don't like it as much unless it's really quite simple, because it takes a long time to go through all the guesses to make it work. I'd rather kind of use a strategy like this, factoring by grouping. It works pretty much every time. Okay, I think I'm going to go through one more with you, and then we'll look at some special, well, let's just look at the special formulas. Okay, a couple of different things. If I had a squared minus b squared, it would seem as if it could not be factored. Okay, but it actually equals this right here, a plus b times a minus b. So I want to kind of draw a depiction of this. So I'm going to draw a little square here. Okay, and I'm going to draw a little square right there. So this is A, and this is B and B. So a squared minus b squared, that's kind of the Utah-shaped figure there. I'm going to kind of just shade it in there. So that's what we're talking about there. Now, if I were to take this and kind of turn it into two trapezoids like this, here's one trapezoid, and then here's the other trapezoid. And then if I were to lay those trapezoids out, so here's 2, 4, something like this, and then the other trapezoid 2, 4, something like that. And then if I were to kind of label the trapezoids, this is B here, and then this is A here, and let's see, this would also be A here, and did I do this right? A, B. Oh, this piece right here is A minus B, and this piece right here is A minus B. I'm sorry about that. So this is actually A minus B, and then here's A, and there's B. And again, this is A minus B, and there's A, and there's B. Okay, sorry about that. That took a little bit of time. But the idea here is you have A minus B for a length, and then you have A plus B, or for a width, and then A plus B for a length. And so it's just A plus B times A minus B. And it works out. So let's just make sure this works. Let's do 3, no, let's go x squared minus 9. Okay, I'm going to rewrite that. I'm going to go x squared minus 3 squared. So we have it in this form here. And then we can say, okay, x minus 3 times x plus 3. And let's just see what happens if we multiply it out. Let's check our work and see. So we got x squared minus 3x plus 3x. So the middle terms cancel out, and you get x squared minus 9, which is the same thing. So that's one formula. It's kind of nice to know, and we're going to actually use that quite a bit. Let's take a look at second formula. This is a plus b squared equals a squared plus 2ab plus b squared. And I'm going to draw just a little, so if this is A here and A there, and then we've got, let's see, something like this. So this is B here and B there. And then this is going to be, and if we can kind of think of this as A plus B times A plus B, and then you can kind of see A times A is A squared, and A times B is AB here, and A times B is AB there, and then B times B is going to be B squared right there. So taking a look at that, you've got that formula. So let's just try one. X plus 3 squared. With the formula, it's just x squared plus 6x plus 9. So a squared plus 2ab. So we just and then plus b squared there. Okay, I'm kind of running on here, but and this was kind of a lot all at once, but hopefully you've got the idea of grouping. You've got the special formulas, and we're probably going to stop it right there. Thank you.